going to talk about is speed. When we talk about speed, as applies to mechanical comprehension, this is like one area of physics or kinematics that we deal with. All right, so when we talk about speed, it's always to remember the base formula, because normally this is going to occur in what we have called distance, rate, and time problems. So it's always good to remember that distance equals rate times time. Time equals distance divided by rate, and rate is equal to distance divided by time. Okay, so these are the formulas that you want to be always constantly. They're going to be asking you how long, how far, or how fast. So we're always going to be looking for distance, rate, or time. What was that?
No, I was just saying, okay.
Okay.
Good. Always to keep these formulas. Yeah.
Yeah, so you always want to keep these in the mix of your mind when we're dealing with distance, rate, and time problems. Now, I'm going to go into a couple basic ones. Now, basically, like, all right, let's say, where do you like to shop? Where do you like to shop at?
Well, I mean, if I'm doing groceries, I guess I'm just always going to Walmart.
Okay, Walmart. Okay. Well, let's say there's a Walmart. This Walmart is 150 miles away. But this particular Walmart, everything is 80% off because they're shutting down this Walmart. All right. So let's say we're going to go down the county road, and the county road is 50. The speed limit is 50 miles per hour. All right.
Okay.
If we have our distance 150, the county road is 50 miles per hour, how long is it going to take us to get there?
Okay, just 150 equals 50. It's going to take us 30 minutes.
30 minutes?
Wait a second. Hang on. 50 miles an hour. Oh, no, 3 hours. Sorry.
3 hours, okay. So when we ask how long, we should have automatically went to the time formula. And T equals 150 over 50. Now, what most people would do is they would say, okay, well, 150 divided by 50. And I wouldn't do that. For rapid math technique, I would kill this zero and kill this zero, and I'll get the same answer. 15 divided by 5 is 3 hours. So I don't waste time, just you working with extra zeros. I don't do that. I just kind of, I simplify it. And you get a time shape wherever you can. So that's a basic one. But sometimes you'll get really crazy ones. All right, and you have to be able to identify the type of distance, rate, time problem. So the first one I'm going to jump into is the round trip.
Okay.
And I got it here somewhere. Okay, so here's our question, and I will present it to you as well. It's going to be a little choppy, but it's all there. and I'll read it aloud.
That's good. I got it.
Okay, an aircraft carrier made a trip to Guam and back. The trip there took 3 hours, and the trip back took 4 hours. It averaged 6 kilometers per hour on the return trip. Find the average speed of the trip. So, this kind of goes in tune with, or runs along the course of your basic formulas. But as a round trip, we have to position it a certain way. All right. So for round trip, we go there and we come back. And then I'm going to DRT and DRT. The distance, rate, and time for the trip going there, and the distance, rate, and time for the trip coming back. Okay. And what else do I want to do? Okay. So we're going to plug in information. This is how we set up a round trip problem. All right, so the aircraft carrier made a trip to Guam and back. You see my arrows. The trip there took 3 hours, so at a time I'm going to put 3H for 3 hours. The trip back took 4 hours, I'm going to put 4H there. And it averaged 6 kilometers per hour on the return trip. Now, if we have 2 pieces of any leg, we can automatically find the third, can't we? Okay.
Yep.
Which leg can we find all our pieces based on what we have, based on what we're given in the question?
Well, we can take our rate and times for our return trip, multiply them together to get our distance, which would be 24.
That is correct, sir. And if the distance from B to A is 24 kilometers, what is the distance from A to B?
Same thing, 24 kilometers.
24. Very good. 4 kilometers. Okay. So at the end of the day, now we have 2 pieces of the leg there, don't we? Yes.
Yeah, like I said, you can then use the rate formula, which is distance over time. 24 divided by 3 is going to be 6.
Very good, very good. Okay, so 6. Whoa. 24 divided by 3 is what?
Oh, I'm sorry. 8.
8, okay. All right. Just wanted to make sure we're on the same page. We established that by looking at there and back. An aircraft carrier made a trip there and back. All right, so that is the round trip. Now you have a second question that I'm dropping on you. And first, I want you to identify the type of problem this is.
Once again, it's another round trip. They made a trip to Vegas and back. On the trip, it flew 432 miles. On the return trip, it went 480. How long did it take there? If it was the return trip, it took 9. So once again, it's another return trip. So the first trip, it flew at 432 miles an hour.
Now I know you're jumping in, but the first thing I want to know is your setup, brother. That's what I want to know.
I got you. So
you should have
this one, arrow out to the right, arrow back to the left for your round trip, and you're going to set your distance, your rate, and time on the top to represent your first trip out, and then the distance, rate, and time on the bottom is going to be for your return trip back.
Very good. All right. So now we're filling in the blanks.
Yep.
Okay. So the process that I use or that I teach is line by line and diagram. You read a line, you diagram it.
Yep.
Read a line, you diagram it. And if you do it like that and chop it up like that, you're not going to have any problems. There will be no distance, rate, and time problem that will ever stump you at all.
Yeah.
All right. So the passenger plane made a trip to Vegas and back. Well, the trip there, it flew 432 miles per hour. Where do I put that?
That'd be the top. That'd be your top rate.
432 MPE. Okay, and on the return trip, it went 480 miles per hour. Where do I put that?
Right at the bottom.
I'm sorry?
That'd be on the rate at the bottom.
All right, 480 MPH. Okay, very good. Now, how long did the trip take there? This is what we're looking for. If the return trip took 9 hours, where does 9 hours go?
That's going to go on the bottom at time.
Okay. So, based on what the question is giving us, can we find anything else?
Yeah, we can find the distance by multiplying the rate and the time together for the return trip.
Okay. Now you might go 480 times 9, but I wouldn't do that. I would just say 40. Sorry, I would say 48 times 9. I would multiply that, and then I'd add a 0 to my answer.
Gotcha. All right. I came up with 4,320 miles. 4,320 miles.
Okay.
For the distance.
Okay, so once we find our distance, then what?
Plug it in up to the top trip for the first time, or for the first distance.
Very good. 4320, right?
Third.
I'm sorry?
Yes, that's perfect.
Okay.
And then 4320 up top.
All right. We have that now. And I just threw in a new shirt. I had a hole.
Okay. All right. And then right off the draw, I see that 432 miles pretty much matches up with the top minus the 0. So you know it's divisible by 10. So you know you have 10 hours.
All right. Okay. Very good. All right. Good job. All right. So, continuing on. Present some questions on the board. Let's say we have a dog, and your dog runs at your dog runs 1/2 hour
Okay.
at a rate of 6 miles per hour. How much distance does the dog cover?
All right. It'd be 3 miles.
3 miles. So
Yeah.
automatically, your mind, mentally, your formula said, okay, well, how much distance does he cover? Right?
Yeah.
Now, you didn't multiply 6 times. Well, you could have. All right. For distance, yeah. So 3 miles is the correct answer. All right. My next question is, what is the average speed of an airplane? All right. So we're looking for rate. And in this particular aircraft covers in 2.5 hours.
Okay. 50. it be 1,000 miles an hour?
No.
Or under? 1,000's too high. It'd be 100,
Yeah,
correct?
too high.
Be 1 mile an hour?
How much?
1 mile an hour?
1 mile an hour. Does that make sense? If I'm
Yeah,
running at
yes.
1 mile an hour, that's gonna. So this is what we do. We're looking for rate. So let's go to our formula. We always stick to our formulas. We say, all right, what's the rate? Rate is distance divided by time, right? So our distance is 250 and divided by 2.5. All right. So we'll come here, 2.5, 250. Now, here's the problem. This decimal needs to be moved over. And
Over,
if you
yeah.
move this decimal over
100.
1, then this decimal moves over 1. And 25 cannot go into 2. 25 goes into 25 one time, and then you fill the zeros up to the decimal. And so,
I tried to move the decimal after the fact instead of the beginning. That's what threw me off. That's my bad.
All right.
I moved it the wrong way, too.
this is where we learn. This is where we make our mistakes, here, not on the test. You can make a million mistakes, I'll make a million corrections.
Yeah.
As long as we get to our target. All right. So, move that along. Okay. So, when we talk about physics and we talk about speed, or a rate. Right. So,
Okay.
if I were to write two formulas, speed equals distance divided by time, and velocity equals distance divided by time. What's up with that? How can two things have the same formula? Why is that? Because this is actually a mechanical comprehension question. They will ask you, what is the difference between speed and velocity?
Okay. Speed is just your measurement of how fast you're going. Velocity, that's like you being propelled forward, or you like the motion of you picking up, I guess, speed up. I'm trying to figure out the best way to word it. I can't get it articulated in my head.
All right. The difference between speed and velocity is, and in physics, we have quantities. We have quantities that have a magnitude, and we have quantities that have a direction and magnitude. Okay. So what do I mean by that? All right. I'm going to tell you. Velocity will be what we call a vector quantity, and speed will be what we call a scalar quantity. All right. So what's that, Kino? Vectors, you just throwing out big words again. And velocity.
What was speed referred to again? What was it again?
Scalar.
Scalar. Okay.
All right. Well, velocity is a vector quantity. So we have scalar quantities and vector quantities. Vector quantities have magnitude and direction.
Okay.
So when the police officer gives you a ticket, you're not getting a speeding ticket. You're actually getting a velocity ticket. Because what do they indicate on there? You were going westbound on Route 22 or Route 80 or Route 40 or I-40. I mean, you know. So I would say, you know, there's a velocity ticket, not a speeding ticket. Now, don't take that to a judge because you'll probably have an issue.
Yeah, no.
Your Honor,
It wasn't like that.
Your Honor, this is not a speeding ticket, and I think you should throw this out. It's actually a velocity ticket. I know. Corny humor. So velocity has direction, speed does not. All right, and we'll move on. Now the next thing we need to discuss is something called acceleration.
Okay.
The acceleration formula goes like this. Acceleration is equal to v sub 1 minus v sub 0 over time. And I will explain what v sub 1 and v sub 0 is. But you need to be familiar with this. All right.
Okay.
V sub 1 is your final speed. V sub 0 is your initial speed. So don't let the little sub thing throw you off. All right. Starting speed, final speed. So final speed minus initial speed, the speed you start at, divided by time in seconds. All right. So the part of the equation that represents change in speed is here. So let's take our Apache helicopter. And let's say, and this is not a replica of an Apache helicopter, but hey, I didn't even know I had this one. Wow, okay. Yeah. All right. So let's take our helicopter. It's in a hover, right? It's in a hover at this point. And it starts to accelerate. So he pushes forward on the cyclic, pulls up on the collective, and he starts rolling. Oh, okay. The main rotor's got to be moving, right? Okay.
Yeah.
So our initial speed is 0. But 15 seconds later, he's moving at, let's say, 30 meters per second. All right. So we're at a hover, and he does this in 5 seconds. All right. So this guy, he's in a hover, and he's cleared to roll. Pushes forward on the collective, pushes forward on the cyclic, pulls up on the collective, he starts rolling forward. We want to measure this pilot or the aircraft's acceleration. Illusion, what was the initial speed?
Initial speed is 0 because we're starting out hovering.
Yeah, so that's your 0. Your V sub 0 is your initial speed. And what is your final speed?
Final speed was 30 meters per second.
All right, 30 meters per second. And how many seconds did we clock this guy for?
5 seconds.
All right, 5 seconds. All right, so when we crunch the numbers, what do we get?
Got 6.
Okay, 6, very good. Now, we say this a certain way. We say it like 6 meters per second squared. 6 meters per second squared. Or you can say 6 meters per second. This tells you that every second we are building 6 meters per second of speed. And this is a concept that a lot of people get lost in. Because something happens here after the first, second, third, fourth, and fifth second. It is acceleration. It is a buildup. And we are building up 6 meters per second every second. So after the first second, we're 6 meters per second. After the second second, we're 12 meters per second. After the third second, we're 18 meters per second. After the fourth, we're 24 meters per second. And after the fifth second, we are 30 meters per second. So acceleration is always a buildup. We are going to discuss the acceleration of gravity. All right. And while we're talking about it, gravity in the metric system and the U.S. customary system. In the metric system, if I release an object, it is going to fall at 9.8 meters per second squared. And in U.S. customary units, it will be 32 feet per second squared. Acceleration is always in meters per second squared or feet per second squared. So don't misconstrue that with a speed or a velocity. All right. But we must understand at 0 seconds, we're at zero. The first second, 6 meters per second. Second, 12. Third, 18. Fourth, 24. And 30 after the fifth second. It is a constant buildup, and we are at different speeds at different points in time. Alrighty?
Yep.
Now, once we know what our acceleration rate is, we're good, because some questions on the test will automatically give you your acceleration. For example, an object falls from a tree, right? No,
Yep.
from a building. We see a little pool.
All right.
We see a little pool at the bottom of the building, and we're throwing pennies off. We're just letting them go and releasing them, and they fall. Okay. A lot of times when they say you drop something, falls from a tree, or we throw something off the building, you're supposed to automatically assume that gravity, or the acceleration of gravity, is in the mix of this question. So they may ask you, how far is this thing fallen in 10 seconds? All right.
Gotcha.
So velocity equals the acceleration rate times time. V equals A times T. And every formula I give you, like that acceleration formula, the distance, rate, time formula, put them on index card.
Okay.
All right.
Trace velocity equals.
So, in metric units, if you want to know how far this thing falls after 10 seconds, we just go to our formula. A, 9.8 times 10 seconds. So we're falling at 98 meters per second. And we don't say meters per second squared because that is not acceleration. Once you say meters per second squared, you're talking about acceleration, not the velocity. And a lot of times the test will trip you up. Let's say if they put on the test question, answer A was 9.8 meters per second squared. That is a sucker punch. Some people are going to say, oh, 9.8, that's my answer, boom. And you got it wrong.
Yep.
So 98. In U.S. customary units, it will be 32 feet per second squared times 10. And so this object will be falling at 320 feet per second. It's 32 times 10, 320, obviously, right?
Okay.
Okay. So now I'm going to give you a question.
All right. This is impossible, dude.
You're back.
All right. Christopher, can you hear me, buddy? Wow.
Okay. So I guess we'll just kill it right there as far as the YouTube live stream. But we're having some connectivity issues right now at this time. So I hope you guys like the video so far. And just remember, this is equals rate times time. The acceleration formula is acceleration equals final speed minus initial speed divided by time in seconds. And finally, once we know our acceleration, we're trying to find velocity. Velocity equals acceleration times time. All right, so thanks for watching, guys, and thanks for everybody checking in. And I'll see you guys soon. I don't even know where the button is now.